Hello, boys and girls, and welcome back to Peak Flicks. This is Math with Mrs. Rossi. I'm so glad that you can join me because we are going to be doing something incredible in math today. So stay along. Today's learning goals. Today, we will be learning how to add fractions with unlike denominators by finding equivalent fractions. You have been so great at finding equivalent fractions. I think we're going to have an easy day today. Follow along, okay? I know I've told you in the past, some students are really nervous about fractions, but you don't have to be. Fractions are your friends. We see them in cooking, we see them in the grocery store, we see them in recipes, we see them in stores, we see them on the clock. We can do this. The questions for today. Why in the world would I need to add fractions? Well, we need to add fractions a lot, so please pay attention. Why do I need to know this? Well, it's part of your life. If you're going to double a recipe, you're going to need to add fractions. If you are going to get a, percentage off, or if you're going to double up some fractions, you might need to add them together. How can I use equivalent fractions to help me? Well, you are not going to be adding any fractions together unless they have the same denominator. So we are going to need equivalent fractions for that. Who can I show this to once I'm super smart about it? You can show anybody you want to. Own that math mind and share it with everyone that you know. Be proud of what you've learned. What do I already know that can help me? If you know about prime and composite numbers, if you know about multiples, if you know about greatest common factors, if you know anything about equivalent fractions, these things are all going to help you. Divisibility rules are especially going to help you, okay? How can I check my work? Well, you can always go back, reread the question, talk it through out loud to yourself, just like I talk out loud and explain the answers to you. You can do that for yourself. What other questions can you think of? You should always have questions. You should always be thinking, well, does this make sense? How can I do this better? Is there any other way I can do this? Keep those questions for your teachers, for your parents, or for somebody else who you can ask for help. Okay. We are going to dive into some examples of fractions to get started. So I've listed the fractions that I know here. So unit fractions, they're probably the fractions that you're most familiar with. 1/2, 1/3, 1/4. Those are mostly the fractions that we have in our kitchen, right? You can have them in measuring cups. 1/2 a cup of milk, 1/3 a cup of oil, 1/4 of cup of water. You're adding it to recipes. Okay. They're also proper fractions. Unit fractions always have 1 in the numerator. You'll notice 1/2, 1/3, 1/4. They all have 1/2 in the numerator. And the numerator is that top number, and the denominator is that bottom number. Proper fractions. They are fractions. It can be any kind of fraction that has a smaller numerator than a denominator. Again, the numerator is on top, the denominator is on the bottom. Then we have those improper fractions. I know you're thinking, improper? It just means that their denominator is smaller than their numerator, which means it can be made into a mixed number, okay? So mixed number is next on my list. And a mixed number is not like mixed up or anything. It's got a whole number like the 2 and a half, which is a fraction. And when we put it together, it's a mixture of a fraction and a whole number. And then we have what we've been working on is equivalent fractions, like 1/4, and that is 1/2 is equal to 2/4. We can also find equivalent fractions for just about everything. When we divide by 1 or multiply by 1, we can grow or shrink, the size of the numbers by finding equivalent fractions. Alrighty, you've been doing great. Follow along. We are going to do some warm-up problems, and then we're going to do our 2 questions of the day. One I'm going to do totally for you. The second one you guys are going to do on your own, and then I'm going to explain how to find the answers. So great for joining us. Follow along, and I'll see you on my side paper in just a minute. How fast can you be? Can you beat me? Today we are dividing by the number 9, and that's it, the number 9. So get ready. Get those thinking caps on, and let's get ready to divide by 9. Are you ready? Get set, let's go. 90 divided by 9 is equal to 10. 54 divided by 9. Let's go, kids. You can say it. It's 6. 18 divided by 9 is equal to, did you say 2? I thought so. 0 divided by 9. That's equal to 0. 9 divided by 9 is equal to 1. That's it, just 1. 99 divided by 9 is equal to 11. 36 divided by 9 is equal to, did you say 4? You would be correct. 81 divided by 9 is equal to 9. 108 divided by 9 is equal to a really big number, and that number is 12. 63 divided by 9 is equal to, did you say 7? I think you must have. 27 divided by 9 is equal to, it's 3. 45 divided by 9 is equal to 5. 72 divided by 9 is equal to 8. How fast are you? You have been getting faster and faster each and every day. And I keep on telling you, go on Reflex Math, do some flashcards, tell your dog, tell your neighbor, have somebody test you each and every day. Your brain is getting stronger, and you're getting way better at math. Keep up the great work, and we'll see you again here tomorrow. Get ready for today's lesson, and I'll see you there. Bye-bye. Okay, now we're ready for our warm-up. So today we're going to be adding 3 different sets of problems. So we have 1/8 plus 5/8, we have 1/2 plus 3/4, and we also have 3 1/4 plus 8 1/3. So you'll notice that we have a mixture here of unit fractions, proper fractions, and mixed numbers. We are not adding improper fractions in these particular warm-ups. But I'll take you to the separate sheet of paper, we'll solve those, and then we'll get on with today's work. Thanks for joining.
Okay, so for today's warm-up exercises, we are adding together fractions. This first question is pretty easy to add together because the denominators are the same. So we're adding 1/8 plus 5/8. So in this case, since the denominators are both the same, I'm going to have the same denominator for my answer, and I'm going to just add 1 plus 5 and get 6. And 6/8 is an okay answer, but there is a better answer. What we can do is we can simplify it. So if I take 6/8, I know that 2 can be divided equally into both of those numbers. So I'm going to go ahead and divide by 2 over 2, which is the same thing as dividing by 1. What I'm finding is an equivalent fraction. So 6 divided by 2 is 3, 8 divided by 2 is 4, and I'm going to get the total answer of 3/4. And I'm just going to circle it as my answer. My next question up is 1/2 plus 3/4. And so I'm going to notice that I have 2 different denominators. And in order for me to add fractions, I'm going to need to have the same denominator. So what I do for that is I find which number can I have that 2 and 4 can both equally go into. And I'm going to just use 4 because I can just double the 2 to get the 4. So I'm going to bring the 3/4 down. I'm going to bring everything else that's the same, and then I'm going to rename 1/2. So in order for me to get a 4 as my denominator, I'm going to multiply by 2. So whatever I do to the bottom, I do to the top. So 2 times 2 is equal to 4, and 1 times 2 is equal to 2. So I really just have my answer for this down here. So then I'm going to go ahead and add together. So 1/2 plus 1/2 plus 3/4 turns into 2/4 plus 3/4. So when I add this together, 2 plus 3 is 5, and my denominator stays the same, fourths. And so 5/4 is the answer, and that's an improper fraction. So this is an okay answer. Again, like the one before, we can make it a better answer. So what I'm going to do is simplify this answer. And since it's an improper fraction, I can go ahead and do the division and make a mixed number. So down here, I'm going to divide 4 into 5, and 4 goes into 5 one time. 1 times 4 is 4. I'm going to subtract and get 1. And my remainder becomes my numerator, and my 4 stays the denominator. So the 1 is going to come up and be the numerator, and the 4 is the denominator. So my great answer would be 1 1/4. So that's my final answer. I'm going to star that one. I'm going to star my 3/4 from before. And I have one more question that I'm going to be working on. So this question, I had to set up and down because I wanted to give myself plenty of space. So we have whole numbers, 3 and 8, and then we have the fractions, 1/4 plus 1/3. So I can split this up and do whole numbers on one side because I'm adding this together. And if I keep 3 and 8 together, this will be 11 as my whole number. And then I just have to add really 1/4 plus 1/3. So again, I cannot add fractions with unlike denominators. So I'm going to make equivalent fractions with a denominator of 12 because 4 times 3 is 12. So my denominator will be 12 for both of these. Okay, so for 1/4, I'm going to multiply that by 3/3, or I'm really multiplying it by 1, and get 1 times 3 is equal to 3, and 4 times 3 is equal to 12. And then for my 1/3, I'm going to multiply by 4/4, or by multiply by 1. 3 times 4 is 12. 1 times 4 is 4. And so when I add 3/12 plus 4/12, I get 7/12. And so I'm going to take this part of my answer and bring it down here, making my total answer 3 1/4 plus 8 1/3. My answer can be 11 7/12. All right, let's get ready for the rest of today's work.
All right, wow, look at those big cookies. So this is the question that we're going to be solving together today. Each large cookie is 5/6 of an ounce, and each small cookie is 4/9 of an ounce. What is the total weight of 2 large cookies and 1 small cookie? Explain your thinking and include a statement of the solution. I cannot wait to get started on this question so that I know how much these 3 cookies weigh together. So I'm going to move over to my little side paper. I'll solve that problem for you, and I will get back with you for the results.
All right, let's tackle this question together. Each large cookie is 5/6 of an ounce, and each small cookie is 4/9 of an ounce. What is the total weight of 2 large cookies and 1 small cookie? Explain your thinking and include a statement of the solution. So if you're like me and you love cookies, this is an easy problem to tackle. So what am I really looking at here? I want to know the total number, or the total weight, of 2 large cookies and 1 small cookie. So I'm going to go ahead and draw 2 large cookies and then 1 small cookie. Okay, so each of these large cookies is 5/6 of an ounce. This is 5/6 of an ounce, and this is 4/9 of an ounce. Okay, perfect. So I want to know what's the total. So I'm going to be adding 5/6 plus 5/6 plus 4/9 because I want to add them all together. So I'm going to go ahead and I'm going to add the 5/6 together, and then I'm going to, whatever answer I get, I'm going to add to the 4/9. So it'll be easier for me to, instead of doing it all at the same time, I can do 2, group them together, and then do 2 more. So 5/6 times 2, okay, is going to be 10/6. And I want to show you a different way to do that, so you don't need to multiply necessarily. Okay, 5/6 plus 5/6 is equal to 10/6. Okay, so altogether, the large cookies are 10/6 of an ounce, or to make that a little bit easier, I can divide 6 into 10 and get 1 and 4/6. That's the same thing. Or if I make that into lowest terms, I can divide each of those by 2. I can get 1 and 2/3. That's how much the 2 big cookies weigh, 1 2/3. Now, I'm going to take that 1 2/3 and I'm going to add that to 4/9. Okay, so in this case, I have, again, unlike denominators. So what I have to do is I have to find a common denominator. So in this case, I know 3 and 9 are pretty friendly numbers. So I'm going to make an equivalent fraction for the 2/3. So I'm going to have the denominator be 9, so I can just add it to the 4/9. So 3 times 3 is 9. So I'm going to multiply the top and the bottom both by 3. So 3 times 3 is 9. 2 times 3 is 6. And I'm going to go ahead and add that together. So 1 6/9 plus 4/9. So it will end up being the answer is 1 10/9. And I can't leave it like that because I have a whole number plus I have this improper fraction over here. So I'm going to have to rename the 10/9. I can split that up into 2. So I can do 9/9 and I can do 1/9. And together the 9/9 and the 1/9 will make 10/9. So this 9/9 I'm going to regroup and bring it over to a whole number and make the whole number, the total answer would be, I'm going to add this here, one more, so this would be 2 1/9 would be my total answer. So over here, 2 1/9 ounce is the weight of 2 large and 1 small cookie. Okay, and then I can go ahead and explain exactly what it is that I have done. So, each large cookie is 5/6 of an ounce, and each small cookie is 4/9 of an ounce. What is the total weight of 2 large cookies and 1 small cookie? Explain your thinking and include a statement of the solution. So, I'm going to start you from the beginning. I have the large cookie is 5/6 of an ounce. The second large cookie is 5/6 of an ounce, and then the small cookie is 4/9 of an ounce. So what I did first is I multiplied this by 2 and got 10/6, but I also showed how I could just add 5/6 plus 5/6 to get 10/6. And so what I need to do after that is add the 10/6 to the 4/9. And instead of keeping this 10/6, I have divided it out, 10 divided by 6, and got 1 4 6. And then I reduced that or simplified that to be 1 2/3. And then I took the 1 2/3, which is the total weight of the 2 big cookies, and I put it over here and added it to the 4/9 of the smallest cookie. So when I added the 1 2/3 and the 4/9, I had to rename this to 1 6/9 plus 4/9, and I got 1 10/9, which was a part of a mixed number, plus it has an improper fraction here. So I separated the 10/9 out to be 9/9, which would be 1 whole, which is this 1 whole that I took out, and then the 1/9 on its own. And so the answer would be 2 1/9 ounce. So I went ahead and wrote this statement of the solution. 2 1/9 ounce is the weight of 2 large and 1 small cookie. And that is the answer for our cookie problem.
Wow, look at me sitting on the couch with these kids. Oh, one of them must be Asani. So this is the problem that you're going to be solving on your own. So after I'm reading the question, you will pause the video, try to figure out the answer, and then when you're ready, I will explain how to do this problem. So, Asani has been reading every day this summer. Go Asani. On Monday, she read for half an hour. Oh, that's a unit fraction. On Tuesday, she read for 3/4 of an hour. Go Asani. And on Wednesday, she read for 1/10 of an hour. How much did she read in total? I think she read quite a bit. Anyway, I want you to pause the video, solve the problem on your own, and when you're ready, unpause the video and I will show you the results. Before you get started, flex that little math brain of yours, and you can begin. I'll see you here when you're done.
Asani has been reading every day this summer. Go Asani. On Monday, she read for half an hour. On Tuesday, she read for 3/4 of an hour. And on Wednesday, she read for 1/10 of an hour. How much did she read in total? Explain your thinking and include a statement of the solution. Asani, good for you for reading. I'm going to organize this information so it's easier for me to understand. I'm going to make myself like a little calendar here, and I'm going to say Asani's got reading on Monday. She read a half an hour. On Tuesday, she read for 3/4 of an hour. And on Wednesday, she didn't read quite as much. She read for 1/10 of an hour. So the question is asking me, from all of this, what is the total? What is the total? So if I can think about this in terms of minutes or on the clock, and we're going to add these all together. We're going to add Mondays plus Tuesdays plus Wednesdays, and we're going to find a common denominator between the three of them. So the denominator is 2, 4, and 10. And I'm going to choose multiples of the number that will work with all three of them. So 4 is a little bit tricky here. So I have to make sure that something will be the denominator that will be for 2, 4, and 10. And the number that I'm choosing is 20. Because 20 is a multiple of all of these numbers, and 20 is friendly between all of them. So I'm going to rename all of these fractions with 20 as the denominator. So for 1/10, I'm going to multiply everything by 2/2, or multiply that by 1 whole. So 10 times 2 is 20. 1 times 2 is 2. So for 3/4, if I want to get 4 times what number would give me 20, I'm going to multiply everything by 5, or 5/5, which is the same thing as multiplying by 1 and making an equivalent fraction. So 4 times 5 is 20. 3 times 5 is 15. And then for 1/2, how do I get from 2 to 20? I multiply by 10. So that's 10 tenths, or multiplying by 1. 2 times 10 is 20. 1 times 10 is 10. So I'm going to go ahead and add all of these up. So I have 10 plus 15, and that would give me 25. Plus 2 more is 27. So it would be 27 20ths. Now, if I have to go ahead and put that in simplest form, I'm going to need to divide this out, since this is an improper fraction. I'm going to divide 20 into 27, and I find that 20 will go into 27 once. I'm going to take that away, and my 7 is going to become my numerator, and my denominator is going to be 20. So this is going to be my total answer with my whole number and my fraction. So I'm going to write Asani read for 1 7/20 of an hour. Monday, Tuesday, and Wednesday. Now, if I really wanted to find out how much that was, if you think in terms of a clock has 60 minutes for each hour, okay? So it would be 1 hour would be 60 minutes. Okay, so that's equal to 1 hour. Now, 7/20ths, if I wanted to know for how many minutes that would be, I need to make an equivalent fraction. So 7/20ths is equal to how many 60ths? So again, I'm making an equivalent fraction. So 20 times 3 is going to give me 60. So 20 times 3 is equal to 60. 7 times 3 is equal to 21. So I can also say Asani read for 1 hour and 21 minutes. So there's always different ways that we can write our answers. If this one is giving it in terms of time, this one is giving it in terms of fractional time. All right? Thanks for joining us on this one.
All right, Peak Flicks math scholars, you have done an incredible job today. But you're not done yet. I'm going to need you to go on to Zern, Reflex Math, or most importantly, fill out an exit ticket for today's work. Please show us how smart you are and what you have learned from doing the lessons here on PeakFlix. Thank you so much for your time, and we look forward to seeing you tomorrow. Have a great day. It was wonderful teaching and learning alongside of you. Take care.